In this video, we're going to look at basic operations on functions. So in this first example, we're given f of x equals 4x minus 2 and g of x equals 6 minus 3x. So we're going to find four different things: f plus g of 2, f minus g of 1, f times g of negative 1, and f divided by g of 3. So let's start with f plus g. So for f plus g of 2, what that means is f of 2 plus g of 2 in expanded form. Okay, so we would find f of 2 by plugging in 2 into x on f of x. It would be 4 times 2 minus 2. That's the f of 2 part. Plus g of 2 is 6 minus 3 times 2. And then we just compute the number from there. So let's see, we have 8 minus 2 is 6, plus 6 minus 6 is 0. So it looks like we get simply 6. Okay, next is f minus g of positive 1. That is a condensed form for f of 1 minus g of 1. Okay, f of 1, let's just do this in our head here. 4 times 1 minus 2 is going to be 2. Minus g of 1, 6 minus 3 times 1 is 3, or negative 1. Okay, next is f times g of negative 1. So that's condensed form for f of negative 1 times g of negative 1. See, f of negative 1 is 4 times negative 1, that's negative 4, minus 2 is negative 6. Because we're multiplying, I'm just going to go ahead and put it in parentheses to be clear. Then g of negative 1 is 6 minus 3 times negative 1. So negative 3 times negative 1 is positive 3. So if 6 plus 3, or 9. So in this case, we get negative 54. And lastly, f divided by g of 3. So that means f of 3 divided by g of 3. F of 3 is 4 times 3, that's 12, minus 2 is 10. G of 3 is 6 minus 3 times 3. Negative 3 times 3 is negative 9. So 6 minus 9 is negative 3. And that's not going to reduce, so that'll be our final answer there. Sometimes you don't plug in a number for x. You can just find products or quotients of two functions and leave them in terms of x. Okay, so that's what we're going to do in this example. Given f of x equals 2 over 5x, and g of x is 3 over 10x squared, we're going to find, first we'll find f times g of x, then we'll find f divided by g of x. So this means f of x times g of x. F of x is defined as 2 over 5x, we'll just copy the whole function, times g of x is 3 over 10x squared. And that is it. Now we can simplify, so we'll go ahead and do that. Looking for things that reduce. The 2 and the 5 don't reduce, the 3/10 doesn't reduce. What we're going to do is multiply across the numerators and multiply across denominators. But it's easier usually to simplify before you multiply. So what I do notice though is the 2 and the 10, I can take out a 2 from both of those to get 1/5. And that's it, nothing else simplifies or cancels. So in the numerators we have 1 times 3 is 3. And in the denominator we have 5 times 5 is 25. And then we'll have x times x squared, so x cubed. Okay, and let's look at f divided by g of x. That means f of x over g of x, which means, okay, f is 2 over 5x, and that's all divided by the function g of x, 3 over 10x squared. This is called a complex fraction because it's a fraction, or two fractions, inside of a bigger fraction. And the way we simplify a complex fraction is to multiply by the reciprocal of this denominator. So we're going to multiply the numerator, which is 2 over 5x, times the reciprocal, that means we flip this upside down, of the denominator. So times 10x squared over 3. Okay, and looking for things that reduce. This time we have 10 divided by 5 is 2. You can put a 1 there if you want. And x squared divided by x, one of those x's will cancel, so I'll just take the squared out and cross out that x. So that leaves us with 2 times 2, or 4x in the numerator, and a 3 in the denominator. And let's practice that again, dividing primarily, but this time with a quadratic function. So in this example we have g of x equals 2x minus 3 and h of x equals 2x squared plus 11x minus 21. So we're going to find g divided by h of x. Well, that's g of x divided by h of x. So that's 2x minus 3 divided by 2x squared plus 11x minus 21. Now I can't tell from right now, from looking at this, if this is going to simplify or not. So what we're going to have to do is attempt to factor that denominator to see if this will simplify further. And that one actually, let's see, 2x squared plus 11x minus 21. No, we haven't done that. Factors, if it factors, it'll factor into a product of two binomials. The first term on one of the terms will have to be 2x, and on the other term will have to be x. Now I'm hoping that one of the factors is 2x minus 3 so that I can reduce this further. So because 3 is a factor of 21, I'm going to try that. This is a guess and check. But if I put a minus 3 there, in order for my last two terms to multiply to negative 21, I would have to put a plus 7 here. So let's check. 2x times x is 2x squared, that's good. My outside terms are 2x times positive 7 is 14x. And my inside term is negative 3x, which do add to positive 11x, so that's correct. My last term is multiplied to negative 21. So then when these factors cancel, we are left with a 1 in the numerator, so 1 over x plus 7. Okay, or we could reverse it and do h over g. Now that we've already got it factored, this will be simple. So 2x squared plus 11x minus 21, that's h of x, divided by g of x, 2x minus 3. So we already know how it factors into 2x minus 3 and x plus 7. So those factors cancel. We have x plus 7 over 1, which we can just write as x plus 7. And that's it for this section on basic operations on functions.